Okay, this is another question from exam number 2. Here you're asked to test your knowledge of the electromagnetic spectrum for frequency, wavelength, and energy relationships. We'll start out, we'll work part A right here. Calculate the frequency in megahertz of radiation, or light, having a wavelength of 6,325 angstroms, moving through the vacuum of space toward the Earth at a velocity of 2.998 times 10 to the 8 meters per second. So we're going to take the equation that you have relating the speed of light to frequency, nu, which looks like a V, and wavelength, lambda, which kind of looks like a Y, or a headless person running with one arm behind their back or something, I don't know. But the part that you're going to have to do first is look at your angstrom measurement. So this is speed in meters per second, and frequency here, the unit for frequency is the hertz or the reciprocal second. They're equivalent. So a hertz and reciprocal seconds, same thing, or what's often called per second, or 1 over s. Now wavelength is in meters in this question, so to get meters per second you need meters and per second. Meters for wavelength, per second for frequency. Well, you've got meters per second for speed, so you're really asked to solve for nu right here, the V looking thing. So nu equals c over lambda. But you can't do the division and get frequency in hertz until you have the wavelength in meters. So you need to do one step first. Convert your 6,325 angstroms to meters. You have a conversion factor for that already, that 1 angstrom is 1 times 10 to the minus 10 meters. So really, that's 6.325 times 10 to the minus 7 meters when you do your math with your exponent. You could also use a calculator if you wanted to calculate that. 6325 times 1 times 10 to the negative 10, and there's your 6.325 times 10 to the minus 7. So that would be your wavelength in meters. Then once you have that, then you could put that into that equation there, and that frequency equals the two. Actually, I'm going to do that down here. Frequency equals the speed in meters per second, 2.998 times 10 to the 8th meters per second, divided by your newly found wavelength, 6.325 times 10 to the minus 7 meters. But remember, that's going to give you frequency in hertz. So you're going to have to go from hertz to megahertz for the problem that it's asking you for. So this is going to come out when you do this math to be in reciprocal seconds or hertz. But right away you need to cancel that out. So 1 megahertz is 1 times 10 to the 6th hertz. So this is going to, meters are going to cancel meters, and you got per second, which is the same as hertz. So per second and hertz gets to cancel out. You're going to be megahertz. So really what you need to do is this is your new wavelength, the bottom number. So I'm going to type in 2.998 times 10 to the 8th divided by this number here. And then I've got to divide by 1 times 10 to the 6th. So, you had your answer in hertz was 4.740. Pull that back up there. 4.7, if you rounded it to the right number of sig figs, 4 times 10 to the 14th hertz. But you needed it in megahertz, so that divide that right there, by your 10 to the 6, and you get 4.740 times 10 to the 8th megahertz. And that's what you write in right here, 4.740 times 10 to the 8th for megahertz. And then we'll keep this number that we got on our calculator before we divide it by 10 to the 6th. We'll keep that for the calculation that we'll use in the next problem when we solve for energy for that.